It is a great honor and pleasure to introduce this video production on mechanically stabilized backfill technologies. We call this internally supported wall system simply MSB. We have spent much time and many resources on research and demonstration projects in this area. CDOT is now on track to save over $10 million annually by utilizing these MSB technologies. We estimate that over $500 million a year can be saved nationwide as other state transportation agencies implement these innovative solutions. Some of these technologies were developed on the Glenwood Canyon I-70 project, which I managed for 12 years. Under my leadership, we aggressively developed and implemented innovative solutions in many areas. Traditional methods and materials would not have allowed us to construct this award-winning project. Technology does not stand alone. It requires professionals for implementation, problem solving, and continual improvements. We call these specialists subject matter experts. Adoption of new technologies requires support from an enlightened management. We will show you in this video how your agency can both save money and provide better service through internally supported MSB technologies. First, let's look at why agencies are not already implementing these MSB technologies. There must be reasons why we're leaving over hundreds of millions of dollars on the table each year.
There are reasons, and these include the human tendency to resist change, to preserve existing paradigms. Technologies, however, are never static. From the beginning of history, man has pushed the limits of his ability. In transportation, we began on foot. And then we domesticated animals to carry us farther and faster. We continually improved the efficiency of horse-based transportation and reached the apex of that technology with the stagecoach. We drove the horse to its limits of power and speed. Technologies reach conclusions. There are indeed limits on the envelope. Technologies continue to evolve. New methods and materials replace the old. The steam locomotive replaced the horse. However, the stage driver was not automatically a locomotive engineer. This analogy illustrates a paradigm shift. Accepted practice in transportation changed dramatically and forever with the introduction of the steam locomotive. A similar technological evolution is occurring in retaining features. These old workhorses are ready for the stable. Externally supported retaining wall systems are being replaced by internally supported earth-reinforced features. And just as in any major paradigm transition, technologists, subject matter experts, must evolve to advance the new paradigm. Our state DOTs are collectively losing hundreds of millions of dollars each year because they do not have subject matter experts in responsible charge of selection and design of MSB features. State DOT engineers routinely design and supervise construction of these magnificent monuments. Yet few state DOTs can design or support construction of these basic retaining systems. Instead, state DOTs often rely on yesterday's technology or proprietary systems. Here is a cast-in-place wall-on piling that cost over $70 per square face-foot to build. A CTI generic MSB alternative designed in-house would have saved hundreds of thousands of dollars on this project. These kinds of wastes of public funds become less tolerable as state DOTs realize just how simple the CTI MSB technologies are. There is nothing special, nothing difficult in design and construction of the basic CTI MSB system. Facing can be as basic as a concrete block. The typical backfill is road base. Reinforcements can be steel strips, wire mesh, polymer grids or sheets, any durable material. CTI generic MSB features are the future in wall and slope technologies. The sooner our state DOTs develop internal design and construction expertise, the sooner we begin saving money.
CTI can teach MSB technology to transportation agencies and assist in developing subject matter experts. We have internationally recognized instructors in the finest course materials. The course is designed for engineers who have no formal training in advanced soil mechanics. What we ask of the student is a willingness to learn a new technology and a commitment to use it.
CTI will assist you in building the bridge to savings.
This is a CTI MSB generic modular block test wall. We're using this wall to demonstrate the principle of internal stability. On this CTI MSB generic modular block wall, we used two types of facing blocks. We added a surcharge and we burned the connections between the blocks and the reinforcements. This is another demonstration wall. These blocks are made of recycled tires, and if they're light, they float. We also cut the connections on this wall. This is our full-scale retaining wall test frame at the University of Colorado at Denver. Here we construct and test CTI MSB retaining walls. The current test includes a full-height concrete panel facade with shredded tires as backfill. This is our full-scale landslide simulator. Inside, we construct landslides and test various remedies. The current test is a new concept we call the CTI Deep Patch. It consists of a negatively battered fabric wall and tire shred backfill. This is our direct shear device. It has 30-inch boxes, which allows us to test a variety of backfills, including shredded tires and sawdust. We can also test the interface between reinforcements and backfills. This is a part of the CTI test frame where we test the connection strength between the modular blocks and the geosynthetic reinforcement. What we have learned over the past several years is that CTI MSB technologies are the future in walls and steepened slopes. They represent the next generation in technology.
CTI generic MSB systems are simple to design and easy to construct. Let's look at a basic system. Backfill is a granular soil. Road base is a good choice. Everyone knows how to build with road base. The easiest facing for construction is a dry cast modular block. Geosynthetics can be used for reinforcement. Placement is as easy as it looks. Geosynthetic strength, spacing, and dimensions can be determined from the CTI design charts. Full-scale testing by CTI shows that this composite of backfill and reinforcement is 20 to more than 50 times stronger than the forces that drive internal failure. High-end geosynthetics have half-lives of several hundred years. Dry cast concrete blocks can be designed to last at least 75 years. And road base is certainly a durable construction material. Safety, longevity, and simplicity are the hallmarks of the basic CTI MSB generic modular block system. Costs for this basic system are quite reasonable. Modular blocks cost $2 to $3 per square face foot. Reinforcements usually cost $2 to $3 per square face foot of wall. Granular backfill is about $2 per square face foot. Labor varies with location, but $5 per square face foot is a fair average for construction costs. At $11 to $13 per square face foot, the CTI MSB generic wall is one of the least expensive systems in the country. The cutting edge of the sword of economy is honed with research findings from CTI and by in-house MSB experts at the beginning of project development. Let's look first at how research has improved the economy of the CTI MSB systems. One of the first discoveries was that internally stabilized features do not require embedment. They are quite content sitting on the ground. While some guidelines suggest embedment of internally supported features, this only increases size and cost. Even a 1-foot embedment adds 20% to the construction. 3 feet adds a whopping 42% to the construction. Where foundation conditions will not allow the wall to be placed on the existing ground, simply excavate the unsuitable soils and replace the excavation with a compacted granular soil. Then build the CTI MSB feature on the improved platform. For the most severe foundation conditions, the designer may consider adding light reinforcements in the improved foundation. But for heaven's sake, don't waste money on a wider or taller wall than is required. The economies in applications with CTI MSB systems are maximized with in-house subject matter experts who participate from project inception. Transportation professionals can identify with the iterative process of finding the best fit for a new or improved facility. In this simplified example, the project manager can move the platform to any of several locations. If a cut is to be considered, the project manager uses geotech subject matter experts to determine subsurface conditions and to provide the most cost-effective design. In the case of bedrock, steep cuts can be used. But if the hillside is subject to landsliding, disaster could occur. The project manager would not leave the responsibility for design of this all-cut cross-section to vendors and contractors after the project has been awarded. This is not always the case with an all-fill section. Most state DOTs do not have MSB design expertise, and they are likely to follow one of 2 courses of action. In the first case, they will design what they know, which is usually a concrete cantilever wall. And if the subsurface conditions are unfavorable, the traditional designer will underpin the traditional wall. These constructions are fiendishly expensive, often 3 or 4 times the cost of MSB solutions. What can be missed without in-house expertise is the least expensive option, a steepened slope. And if the foundation is weak, then MSB designers can use durable, lightweight fills such as shredded tires, shredded tires make a good backfill for walls and slopes. Sawdust can be used as backfill. Expanded polystyrene is an excellent construction material. These modern designs take advantage of the principle of internal stability. No facing is needed except to prevent erosion. Several systems are available to reinforce the backfill and prevent erosion. This steep and slope demonstration project is a joint venture of CTI and Tensar Earth Technologies. The principle of internal stability can be illustrated by comparing a soil anchor with a segment of reinforced earth. If the nut of the soil anchor fails, the system fails, whereas the most important role of the facing block on the internally supported system is preventing erosion. Reinforced steepened slopes and walls differ only in the angle of the face. Once the angle of repose of the backfill material is exceeded, the reinforcements take most of the horizontal load. The other choice a DOT may make is to simply draw a vertical line and leave the solution to contractors and vendors. This avoidance of responsibility denies the project manager the assistance of subject matter experts in wall selection during project development. An approved list is no substitute for internal expertise. Put the DOT people to work. Let them assume an ownership role and advance the MSB technologies. Our DOTs have capable engineers who would rather be self-reliant.
Research pays off only when it is implemented. Let's look at applications of CTI MSB technologies.
CTI MSB subject matter experts provided a solution to this space constraint that a contractor probably could not. A highway widening was requested by a township, and they also wanted to save a grove of trees. A traditional, externally supported system would have damaged the trees. Any embedded system would have damaged the trees. A CTI MSB generic wall was the optimum solution. A truncated base was selected to minimize traffic disruption, and the wall did not require embedment. A state DOT saved at least $1 million with non-embedded MSB walls over an industrial site that was known to have contaminated soils. Externally supported walls would have required excavation into those soils. Thousands of feet of these temporary walls were constructed. Milled asphalt was used as backfill. This one project will pay for the MSB generic design squad for years to come. Here is yet another example of saving hundreds of thousands of dollars on a single project. Transportation professionals will appreciate the differences in time as well as cost between these two constructions. This CTI MSB generic system on this project utilized timbers for forming and facing. These treated timbers are approved for house foundations. Embedment was a nominal 2 inches. Geosynthetically reinforced road bases and wall backfills have been used all over the world for many, many years. There are tens of thousands in service at this time, and there are hundreds under construction at this very moment. Mechanically stabilized backfills are the future in retaining walls and steepened slopes. MSB systems are versatile and can accommodate many facades.
CDOT has adopted internal responsibility for MSB design. We proved through a trial implementation program that millions of dollars can be saved each year in Colorado with this technology. The paradigm shift isn't easy and requires a commitment from the top down. MSB technologies are the future, and the Colorado Transportation Institute can provide a valuable service in moving up the ladder of technological advancement.
CTI will assist your agency in developing MSB subject matter experts.
All of us in transportation are aware of the shrinking dollars. Our maintenance efforts just aren't going to be able to keep up with the deterioration of our infrastructure. We're losing the battle to preserve our roads and bridges, but we have to find new solutions. Raising taxes and doing business the same old way won't fly in today's political climate. Laying off maintenance workers is not a good solution. Canceling construction projects is not a good solution. Better science is a solution. We can do more with less through technology. All of us believe that research pays off, but just doing the research isn't enough. Here at the Colorado Transportation Institute, we stress it's the implementation of research that really starts to pay off. Research is an abstraction. Few of us in our DOTs actually perform research. Instead, what we do is implement research findings using the new and better technologies. Of course, we can't blame today's accidents on yesterday's design choices, but we do know this. The decisions we make today, say to use the CTI generic retaining walls, can save money, and that money can be invested in the future, in finding ways to reduce accidents, in improving our pavement quality, in rebuilding old bridges. That's the value of savings. How do we communicate the value of savings to our design groups, to our construction forces, to our maintenance crews? It begins at the top.
Top management holds the key to doing our jobs more efficiently. We're the ones who set the direction and allocate the resources for this department. This is why here at CDOT, we encourage all our engineers to use new and better technologies. This is why we encourage them to use CTI generic walls.
Top management can provide the bridge, the connection. CTI's generic MSB walls can save DOTs hundreds of millions of dollars a year. And we'll support your staff so you can indeed fully realize these savings. We'll help your staff become self-sufficient, design in-house, support construction crews in the field. But it's up to top management to facilitate this training, to facilitate change.